welcome back to that is your channel Physics by Imagination. So in this class we are going to understand about periodic classification of elements. So first let us understand without wasting time, that is in crash course, elements. So what is element? The children, element means it is made up of same number of atom. It is made up of same number of atoms. That is called element. If it is made up of different atoms means compounds. If it is same means elements. If it is a different number of atoms means what, children? Students, that is compound. And we should know what is Z, what is A, what is N. The children, this Z is called. So what is Z? This is called atomic number. What is A? A mass number. Or we can call atomic mass number. And this is neutron number. The children, what is Z means atomic number. Consider an atom. At center, nucleus is present and around this electrons are revolving. Very simple. Now here protons plus neutrons are present. And here, very important, distribution of electrons in the atom. There is a general formula, 2n square. So this is K shell, L shell, M shell, N shell. So number of shells will be increased, K, L, M, N. Okay. So now here, if I put n is equal to 1, in K shell it is going to have 2 electrons. Put n is equal to 2, 4 to the 8 electrons. This is K shell, this is L shell. And put n is equal to 3, that becomes what, children? 3 square means 9, 9 to the 18 in the M shell. Put n is equal to 4, 16 to the 32 in the N shell. Means this is way of distributing the number of electrons in the various shells. That is K, L, M, N. Now what is atomic number means? It is nothing but total number of protons in the atom. Total number of protons means atomic number, denoted by symbol Z. Mass number means total number of protons and neutron number. So I can write as A is equal to Z plus N, N is equal to A minus Z. By using this we can find number of neutrons. This is all about introduction. Dear children, let us come to main topic. That is, we know that periodic classification of elements. Dear children, this periodic table, we have nearly 118 elements. Among 118 elements, okay, we have 90 elements are metals, 22 elements are non-metals, and remaining elements are noble gases, that is semiconductors, metalloids will come. Okay, so just remember 90 elements are metals and 22 elements are non-metals and remaining all metalloids, semiconductors, etc, etc. This is introduction part. Let us come to the point, Doberer-Reiner's law of triads. So as I told you, what is mass number? Total number of protons and neutrons present in the atom is called mass number. So now here, when I go on increase atomic mass, I am going to take general, children, because generally why I am taking? To make you understand very easily. If I take carbon, okay, nitrogen, oxygen, 6, it has atomic number 6, proton number 7, 8. Now 6, and here we can take 12, 14, and here 16. Now what is telling here? According to Doberer-Reiner's law of triads, Doberer-Reiner's law of triads, it is telling that when we go on increase the order the elements according to their atomic masses, So in the textbook they have taken calcium, okay, rubidium and strontium. So you can take generally. This I don't know, nitrogen. This atomic mass I want to find. So you take as A, B, C. The atomic mass of the middle element that is B is equal to average atomic mass of the beside elements. So it becomes, that is A plus B divided by 2, that is A plus C divided by 2. A is 12, this is 16. So now 16 plus 12, 28. 28 divided by 2, nearly get 2 1 ja, 2 14 ja. So atomic mass of this is 14. So this is nothing but, according to Dobereiner's law of triads, means when we increase atomic masses in increasing order, then atomic mass of the middle element is sum of the average between the beside elements. Or we can tell that the atomic mass of the middle element is average atomic mass of the beside elements. Simple. Atomic mass of the middle element is average atomic mass of the beside elements. Okay, so we covered this one. Next, let us move to Newland's law of octaves without wasting time. So Newland's law of octaves, it means what, children? Very simple to understand here. That is, what he is telling here: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. So he is telling that octaves means 8. In the periodic table, every 8 element, I mean 1, 2, 3, 4, 5, 6, 7, 8. So now mean every 8th element, they are going to have same properties. It's telling that when you go on increase the atomic masses, then every 8th element is going to show same nature, same physical and chemical properties that are stated by whom? Newland's law of octaves. So did this law explain for all the elements? No, children. Actually, this law explained only some elements. It could not explain about other elements, new elements. It told just 30 elements are present. Oh, Dobereiner's. Next, Newland's have come, and he told that we can find 51 elements. By using this property, this Newland explained 51 elements. And here, this is applicable only till calcium, children. After calcium atomic number 20, this law is failed. These are the drawbacks of Newland's. First one is, it did not explain for other elements which is more than 20, and it could not explain for new elements which was invented, and he told that only 51 elements are there. That is the greatest drawback by Newland's. Next, let us understand, that is third one, Mendeleev's periodic table. The children, among 4 questions, we can expect easily 1 MCQ. So he is telling that the properties, the physical properties of the elements are directly proportional to their atomic mass. Write down the physical properties of elements is directly proportional to their atomic mass. So you should remember, children, atomic mass is nothing but mass number. Mass number means that is total number of protons and neutrons. This is statement of Mendeleev's periodic table. And he explained many elements. But what are the drawbacks of Mendeleev? He could not explain for hydrogen atom, because hydrogen is the lightest element. He could not explain about that. And he could not tell any information about isotopes. Means they have same atomic number but different mass number. And also he could not explain about how to arrange lanthanides and actinoids. These are the drawbacks of modern periodic law. After that, we come to the point, that is Mendeleev's law over, children. Now modern periodic law means here drawbacks here, could not explain about isotopes. It did not arrange isotope of hydrogen in clearly, and also he could not explain about arrangement of lanthanides, actinides, and he could not give information about noble gases. These are the drawbacks of Mendeleev's periodic law. Now modern periodic law, very simple. The physical properties of elements are directly proportional to their atomic number. Means this is successfully explained all the properties of the elements. Means what is atomic number? Total number of protons. I am repeating once again, that is the physical and chemical properties of the elements are directly proportional to their atomic number. Means modern periodic law. Atomic mass means Mendeleev's law. So after that we move to the important point. So that is variation of different physical properties of the elements. First one, let me take atomic size. This is first one. So what is atomic size? Atomic size. If I consider an atom, the distance from center of the nucleus to outermost shell of the atom, it is called atomic size. From nucleus to outermost shell of the atom, outermost shell of the atom, that is called what, children? Atomic size. So here very important point, in the periodic table we have 180 elements. Okay, among that we have 7 periods and 18 groups. Very important. So many times they asked it in the MCQs. 7 periods and 18 groups. Okay, so this is crash course, so I am focusing on only important topics. 7 periods, 18 group. Now here atomic size, if I go along the period, so in the periodic table if I go along the period, so what is going to happen, children? In this periodic table, if you go along the period, if I come down the group, these are all periodic table, children. Okay, so you can go through that easily. Along the period, atomic size decreases. So you write down along the period, this is decreases. Down the group, that is increases. So in the examination they'll ask you reason. Why does it along the period decreases? Why does it along the period down the group increases? Because if I go along the period, the nuclear shells will be decreasing. If I go down the group, the nuclear shells will be increasing. So if nuclear shells are increasing means the number of electrons are going to be reside more and more in number. Hence down the group atomic sizes increases, along the period decreases. And one more, children, this is along the period decreases, down the group increases. Even this is for second property, that is metallic nature. Down the group increases, along the period decreases. So here nuclear charges in the nuclear shells increases, down the group, that is all about atomic size. But here, what is metallic nature? The tendency of the lose the electrons. Okay, they are going to give the electrons, excess of electrons. That is called metallic nature. So metallic nature, that is along the period decreases, down the group increases. Why? Because along the period what is going to happen? There is an increasing in effective number of nuclear charge density. Okay, hence it is not allowing to easily donate the pair of electrons. But here there is a decreasing in, that is effective number of nuclear charge density. Hence it can donate the pair of electrons easily. So metallic nature along the period decreases, down the group increases. Last but not least, non-metallic nature. Same thing, children, vice versa. That is down the group decreases, along the period increases. So this is all about periodic classification of elements. Dear children, here I have focused on important concepts. Okay, so I hope you understood and prepare well for exam. And if you understand this chapter, please like it and share and subscribe. Thank you.